Hello, everybody. Thanks for joining. My name is Niels, and I want to talk with you about production systems and how artificial intelligence will bring these production systems to a complete new level. Slip to the next slide. So production systems are a methodology to enable lean production. It was originally invented by Toyota, the Toyota production system. The introduction of a production system had a huge positive impact on manufacturing regarding performance and productivity. And one of the core principles of lean production is transparency. When you walk around in a typical manufacturing site, you will see all kinds of pinboards with a lot of paper on it. And this is how transparency is achieved still nowadays in the 21st century. And with all this paper-based management in production systems, we face some difficulties. It's a great system, but of course, we are lacking some of those issues. For example, applying and monitoring standards across multiple locations is a challenge. Also, data exchange along the value stream is a challenge. As everything is written down on paper, makes it difficult. Also, knowledge exchange across your organization is difficult. Very difficult also task tracking and progress tracking in real time. And you have to put in handwriting manually to Excel back and forth, which creates a lot of, let's say, unnecessary efforts. But we have a solution for this, the industrial Internet of Things. So what we bring together is lean management and the IIoT. And how we call it at Bosch, when we talk about this, we talk about the factory of the future. So you have real-time insights and fast reaction at your fingertips. That's the idea we're pursuing. So bringing the data to a dashboard, bringing it to the shop floor, and reducing all the paperwork. That's a great first step we achieved by following the factory of the future. So the factory of the future is a great enabler to support the lean principles. You can see here on this slide, on the left side. And all those principles have one common goal. They want to achieve the true north, which is here on the right side. It's to achieve 100% added value, perfect delivery, 0 defects, and one-piece flow. So this is all very great. And actually, what the nice thing is, when you set up the factory of the future, the fun part starts after that. So looking at fault prevention and now looking at how artificial intelligence can actually enable fault prevention or bring fault prevention to the next level. We take a look at tightening. I was dealing with it a lot in my time at Bosch with tightening process. Everybody knows of you knows tightening. It's all about force. It's all about angle. It's all about time. The screw needs to sit in the right position. You have to have the right torque to it, but not too much. It has to be sit tight, but not too tight. And in German we have a famous saying, nach fest kommt ab. So after tight, it's broken, So actually, it's a very complex process. And if you think about, you have thousands of tightening processes every day in your manufacturing plant. You face kind of some challenges, even if you're using IT solutions like in the factory of the future. So what we are doing today is we are looking at curves. We are doing static monitoring with windows, and we are having those digital parameters for the tightening system. All very great, but we still have challenges or ways for improvement. For example, the static monitoring windows have blind spots. It's very static. The parameters are based primarily on experience and trial and error. Also, we have huge challenges for the knowledge transfer of the process know-how. Additionally, we have the challenge that line must be ramped up faster. And when I talk to customers, I usually hear one thing. They say, "Well, we are a manufacturer. We don't want to become process experts in tightening. We just want to have okay tightenings in our manufacturing process, but I don't want to be the chief expert in tightening processes." So when you look at this, you actually see the potential of artificial intelligence. So if you think about it, you're doing thousands of tightenings a day. With each of those tightening, with each screw, you can train an algorithm. You can teach it every single day. And by doing so, you can actually create algorithms for tightening, for example, who are able to analyze processes in real time automatically, who are trained continuously, who detect anomalies, and who are able to suggest parameters for the right way to configure your tightening systems. And with each day, they get better and better and better. And this is just one example we're doing currently in practice. And if you think about all the potential that is out there with those self-learning algorithms and those repeating steps happening over and over again, you can imagine the impact that artificial intelligence will have on production systems. Well, some people might see this as a critical development and might have fears regarding this topic of artificial intelligence in manufacturing, but this is actually not our perspective on the topic. We see artificial intelligence as a potential teammate. So a teammate that is actually able to support you with certain tasks in interaction with humans and machines, but who is, of course, like a teammate, not perfect in everything. And the way to become a teammate is going from having an assistant who you have to teach and train every day, and you don't get anything back. In the second step, you have, an assistant who's maybe monitoring something, so you get maybe basic alerts. And then at the third level, you will actually have a coach, so somebody who gives you a hint on what you what you could make better. This model is something I came across the Harvard Business Review when I read it, and I really liked it because that's actually how we are doing and introducing artificial intelligence in our manufacturing sites and in our software solution. So to wrap this all up, when we talk about production systems, Internet of Things, and artificial intelligence, we see lean production systems. That's where we're coming from. Nowadays, we have the factory of the future. The Internet of Things creates potential to digitalize processes and enables us then to go to the next level. This is the introduction of artificial intelligence into our software. And with our Nexceed IIS portfolio, we are providing a frame to integrate these steps into a one common platform. So thank you very much for your attention. I hope I could give you some insights on the topic of production systems and artificial intelligence. And I am now open for your questions.
Thanks a lot, Niels, for these interesting insights. Obviously, artificial intelligence is one of the key topics of the future for many companies. So very interesting topic, and I think of a lot of interest from the audience. We talk about artificial intelligence for a long time, and specifically the use case of artificial intelligence in manufacturing and in logistics, right? This is your topic, that's in the industry for a long time. What do you consider being the most important hurdles for companies to introduce a technology like that into their processes? And what strategies do you see to overcome these hurdles?
Okay, so as a strategy to introduce artificial intelligence in your company is, as I showed, there's this organizational step where you start from, seeing it as an assistant, monitor, coach, and so on. But most important is you have to look at use cases which are very promising and where you think you can create the greatest benefit. This is one perspective, so the business perspective. You need to have the business value. And of course, you need to have the data available. So for example, when we talk about process curves and processes in general, you should be able to correlate them with quality data. So you have the tightening curve and you also have the quality result, which says it was okay and not okay. If you have those batches of data together, you could put it to the algorithm and you can start working right away. That's what we have done with tightening, also with laser welding and other processes as well. So these are the factors. Organizational approach, use case should be very promising, and the data should be available, but both sides, from the process, but also from the quality side.
Right, thank you. And coming to a question from the audience right now, which is, could you give us a further concrete example for the use of AI in manufacturing and or logistics?
An example for, well, as I have illustrated it, we are doing this for tightening curves right now. So we have an algorithm which is actually able to be trained and to have to calculate a health like a health indicator of the tightening curve. This is a very concrete example we are doing today. So this solution is already in practice, and we have another very interesting solution right now where we're talking about intralogistics. And you have those intralogistics, you have all those milk runs and the flows of parts everywhere, and you should be doing route optimization. And that's one of the classic big data or AI topics, route optimization. And we are working there together with our artificial intelligence center from Bosch to have an algorithm that actually is proposing a dynamic route optimization, which is much more efficient than the static route planning, which is done by a human being just saying going in circle every 2 hours. This algorithm is actually looking at demands, availabilities, and so on, and then calculating a dynamic route throughout the plant. These are just two examples regarding artificial intelligence, which are running today.
Great. Thanks, Niels. Thanks for these interesting insights. Really looking forward to hear more about the use of artificial intelligence in manufacturing, since I think this is a really cool topic that's of high interest for many stakeholders in the industry. Thanks a lot.
Yes, thank you. Thank you for having me.